Good evening, everyone, and thank you for joining me. We have quite a bit to talk about, and first thing on my agenda is talking about the La Nina. I mean, this La Nina is just off the charts. Let's look at this right now. Let's do an animation right now. Let's look at the SST trend over the SST anomalies over the past month. Started out as a weak La Nina, quickly progressed within only a few weeks into a moderate to strong La Nina. There are actually anomalies showing as much as 6 degrees, just a few hundred meters just below the surface. In fact, some of these waters are being upwelled. Right there, boom. There's an anomaly of 4 to 5 degrees centigrade below normal. So this is a very strong La Nina here, and it's starting to actually gain some steam here. I mean, look at this here. Even though you have a little warm water there, it's quickly being overrun by the La Nina. And very shortly, this La Nina will take over most of the Pacific, and it may even send some cold water upward. But usually the trend is that it's actually being upwelled, but it's going to basically make this whole region very cold. As the cold water reaches to the surface, it will spread out across the surface and may eventually, though they go have currents below, some of this colder water will spread out across most of the eastern Pacific, especially the equatorial Pacific. And this will inhibit the storm development over the eastern Pacific. So you'll have more maybe typhoons across the western Pacific, but you'll have less across the eastern. And this factor will allow for many storms in the west coast. East coast. You'll have many storms forming in the Atlantic. Right now, this is what 2005 looked like in August. Right now, this is where we are, around June 18th, right? So, this is what it looked like back then. And so you had a lot of cold waters, some warm, some cold. It looked pretty scattered. But now, this is what the world looks like. Let's go back out. And let's look at the Atlantic right now. Just look at it. Look at the waters here. I'll pay attention to the equator later, but look at this. Look at all these warm waters. That is an anomaly of 3 to 4 degrees centigrade above normal. The waters are incredibly warm here, guys. You had some cold waters, but then it just quickly got flushed out by all this warm water here. Just got completely flushed out. There was even a 4 to 5. Wow. Right here, there's actually a 4 to 5 degree. Wait, that's 90 days. I don't need 90 days. I need 30. Yeah, clicked on the wrong link. Okay. Just look at this, guys. In the past 30 days, look how quickly everything changed. From some cool waters being here to some warm. There we go. Let's go to June 18th. I'll show you what I mean. Boom, and you have some really warm waters. I mean, guys, look at this anomaly of 5 degrees centigrade above normal. I mean, look at these water temperatures being so warm. There might even be 8 to 9 degrees centigrade readings in there. I mean, look at this warm tongue right off of South America. just had to get something to drink. Now that I'm back, yeah, that's. I just wanted to click there to see what the theory was about. It could be right, actually. Um, I mean, I don't know if it's true or not, but this quake looked like it was pretty recent. It just looked like it just happened. It was just an earthquake, so let's go. Alrighty, let me look at Swarm right now. Looks like that was that earthquake there. Look at spectrogram right now. I think that was a quake that quake was probably the one that was near that island there. Let me look at Google Maps. Show you what island that is. So, Garioli Island. So it was near Garioli. So Garioli. That's the one. There. Let's see if it's loading. Waiting for it to load. Wow, Swarm is kind of taking a while right now to load. It's probably because I'm having so many windows open. The server record no heliquarter data. No heliquarter data. Okay. I have a feeling it's gonna be the same thing. Oh wow, that's a 4. That's probably the 5.1 and the 5.2, and it looks like it was a sequence too. Don't get me wrong, the quake was pretty far away, and there you go. Let's okay. Don't get me wrong, the quake was pretty far away, so it was pretty far, guys. It wasn't like it was close. There was a considerable distance from that earthquake to that island. So maybe like 30, 20, 15, 20 kilometers out. And it looks to be more subduction related. So you're probably gonna have dominantly lower frequencies since it's a non-volcanic quake. There you go. Definite up and down signatures. Definitely thrust. You can see most earthquakes are up and down, but you can see definite up and down, up and down. Usually most earthquakes are more. They're all show up and down, but like with a strike slip, it's the wavelengths are different with a strike slip. So let's look at the spectrogram plot. So definitely lower frequencies as expected, but also it's further away, guys. But definitely lower frequencies. Usually lower frequencies mean usually harmonic tremors are dominantly higher frequencies. And if you look at the Cleveland volcano just before it erupted, actually, you can see how the frequencies actually shot up, but it was right near the volcano. So then you had another one. Look at that. So what you're seeing here is background microseisms, background noise from oceans. That's what you were basically seeing at the at most Aleutian volcanoes, you're going to see this background noise from all the ocean. You're going to see it here. You're going to see it everywhere, basically. So those are not. These are not harmonic tremors. There's no harmonic tremor that is occurring right now. Ben Fariello did a video. He mistook that back then that microseism for harmonic tremor, but actually he's the one who taught me what a background microseism is. Basically, ocean noise, just other background. So this is basically the code of the earthquake, and there it disappears into the background. And yeah, right about here is when so you're still seeing aftershocks. Every one of these little spikes is basically an aftershock from the earthquake. And here's the thing. Before the earthquake, you see harmonic, not harmonic, just background microseisms. Boom, see how it's noisier? That's the earthquake. That's why you're seeing some of that blue stuff here. So this is background microseisms, and the reason it's redder is because of the earthquake. You can still see that there's still tremors going. The earthquake was 5.2, by the way. This was the 5.2. This is the 5.1, and then you had another pretty good sized aftershock, maybe magnitude 2, magnitude 3, and this was a considerable distance away, guys. This was not. Okay, there's another one here. Another little aftershock here. You can actually see. It's nominally lowered frequency because it was pretty far away. Usually, when you're seeing harmonic tremors, they're usually between 15 and 20 hertz, or they could actually have a wide range of frequencies, but usually harmonic tremors have a higher frequency, especially the stronger the tremors, the higher the frequency. For example, these are little earthquakes possibly on the volcano or near the volcano. This is before the earthquake, by the way. And you can see these are probably distant ones. Like, for example, let's look at Cleveland right now. So I'm going to show you Cleveland. Oh, I can't seem to find it. Let's look at Katmai. Katmai is one of the more active Aleutian volcanoes. Also used to be caldera. So no heliquarter data. So nope. It looks like this is a global network here. The KABR, it even has a little Earth symbol there. So I'm not going to be talking about hurricanes right now. Looking at right now strictly at earthquake and volcano areas. Of course, volcanic tectonic earthquakes also produce lower frequencies than normal earthquakes, because volcanic earthquakes fracture rock more rough, like mostly fracture rock. So yeah, again, like, okay, that looks very noisy and messy, and I'm having trouble reading that right now. No heliquarter data. Let's look to a global network then. EHZ. Okay, yeah, I can't even read that at all. Like, it's completely illegible. And nothing to note here. It looks like Naga's pretty good. I mean, Katmai's pretty good. Garioli's pretty good, and Makushin, yeah. Let's look at Spur, Cleveland. Great Sitkin is another interesting one. And let's look at all earthquakes across the United States. Ooh, Long Valley. Is that Long Valley? Yep. Just south of Long Valley. You had a 3.0. Wow. 3.0. Let's see if it's part of a swarm or single event. Looks like it's a single event. Happened about an hour ago. It's a little under an hour ago, about an hour, 10 minutes ago. Just happened. 3:05 is actually 11:05. Actually happened a couple hours ago. At a point 8 here, right in the caldera. So some background earthquakes. Looks like this one almost happened on the line. You could actually almost just put a line through it here almost. But it's probably just coincidental. But you do have a lot of earthquakes that occur in this area. In fact, if you do 7 days on magnitude, you're going to find it's not just a line. It's more of a centered on the caldera, more like. In fact, let's look at the Cascade volcanoes right now. Let's look at St. Helens. St. Helens had a single earthquake. Let's look at 7 days on magnitude and one quake. First one at St. Helens was a 0.3. So 0.4 was an explosion, probably mining related. Of course, Ashford, Washington looks like this is related to a volcano. You can see how there's all these rivers diverting from here. This is a volcano here, guys. This is likely a volcano. Looks pretty close to the surface. And let's see where volcano that is. I believe that's Mount Adams. Maybe Rainier, I think. Yep, Mount Rainier. Wow. Right over Rainier. In fact, right near the peak, actually. The thing is, Rainier hasn't erupted in a very long time. There has not been an eruption at Rainier. I think. It's a stratovolcano. Last eruption, they're saying that the 1894 eruption. So it last erupted in 1894 to 1895 when small summit explosions were reported by observers in Seattle and Tacoma. Mount Rainier's next eruption might be of similar or larger size and could produce volcanic ash, lava flows, and avalanches of intensely hot rock and volcanic gases called pyroclastic flows. But the thing was, the 1894 eruption was a very small eruption. It was basically pharaohomagmatic eruptions. There's no images of the eruption, unfortunately. So that's, I believe, 1980. Yeah, that's Mount St. Helens. The latest eruptions from the Rainier volcano. At least 14 dates between 1820 and 1894. Youngest blanket of pumice and ash. Pumice and ash from Mount Rainier. Wait. Recent mapping of the geology of Mount Rainier National Park brought forward no geological evidence to substantiate such recent activity. Because, brief notices in book and roll reports report eruptions. It's 14 days between 1820 and 1894. Depictions of the supposed eruptive activity are vague. Maybe it was just a small summit eruption that didn't really affect the whole park. It was maybe some trapped gases that were escaping. Very likely it was what you would call a hydromagmatic eruption. Descriptions of the supposed eruptive activity are vague, however, and in no case is that there a clear record of the emission of new lava or ash. Recent mapping of the geology of Mount Rainier National Park. Recent mapping of the geology of Mount Rainier National Park brought forward no geological evidence to substantiate such recent activity. The youngest blanket of pumice and ash from Mount Rainier consists of two or more distinct ash falls. Both tree ring and radiocarbon methods of dating indicate that it was deposited about 550 to 600 years ago. Mount St. Helens, on the other hand, was an eruption more recently. Historic accounts, November 1962, they said this. They're already talking about Mount St. Helens. Wow, even then. Mount St. Helens, on the other hand, this is when it was still a full cone without any crater on it. It was beautiful. Mount St. Helens, on the other hand, was in eruption more recently. Historic accounts of eruptions of this volcano in 1831, 1842, and 1843 appear to be reliably documented, and there's also geological evidence of very recent activity. And of course, only 50 years later, 20 years, 18 years after this report, it completely blew its top off, or basically shredded its top off and then exploded from the earthquake. This Cascade Range, extending from the Canadian border to Northern California, is surmounted by many snow-covered volcanic cones that give scenic grandeur to the predominantly forested landscape. 11 of these tower above 10,000 feet. Most of them rose during the Pleistocene and recent time, but only a few remained active into the historic era. People still living remember vividly the 1914-1950 eruptions of Lassen Peak, outbursts of Mount St. Helens, which dusted ash over the surrounding countryside, were witnessed by early pioneers in the Columbia River region. Fremont, 1845, anonymous, Fremont, and Indian legends tell of earlier activity. Mount Baker, Mount Hood, and Mount Rainier, the latter of them called by its indigenous name, Mount Tacoma. I'm not going to use the word Indian, it's kind of racist, but I'm going to say indigenous. By its indigenous name, Mount Tacoma, are also reported to have been in eruption during the last century. But accounts of their activity are vague, and published records do not agree. For example, Mount Rainier, the highest elevation, 14,410 feet, is reported to have erupted on at least 14 different occasions between 1820 and 1894, but whether they're actually eruptions or some other phenomenon is open to question, for in no case is there a clear record of the emission of new ash or lava. This paper attempts to summarize and evaluate the historical accounts of Mount Rainier's activity, chiefly in the light of information gained during an investigation of the geology of Mount Rainier National Park. So this is from November 1962. So this is 58 years old journal. So let's look right now at, again, the USGS. Let's see if we can find any earthquakes at volcanoes right now. Any. Let's see. There's a pretty strong one at 4.2 in Alaska. Let's see. Not volcanic. It's basically too far. Even Hawaii. That's basically those long period earthquakes. Probably a few people felt that, definitely. 3 people, Hawaii felt it. Looks like even northern Hawaii felt some of it. So there are definitely probably some felt reports here. Even Yellowstone, there's hardly any activity there. There was a small swarm, but let's see, there might be one or small earthquakes there. One. A 0.8, 2.9 kilometers in depth. Okay, that's time for me. It's getting really late. I have to go to bed now. Thank you all for watching. And again, I'm calling for 18 to 22 named storms, 10 to 12 hurricanes, or 10 to 14 hurricanes, and 8 to 10 major.